Hi, in this video, we will discuss about the partial differential equation. You should have learned the ODE, and you should know ODE consists of one independent variable. For example, in this case, we have ODE because you have one independent variable t here. And in this case, so this is called the system of ODE problem because you have multiple equations for the ODE which consists of one independent variable t here. In this study, we will continue to solve the PDE problem. So PDE is the extension for the ODE where you have two independent variables or more. For example, in this case, you have the independent variable t and x here, and you want to find the solution for the temperature with respect to the time and space. Since you have more than one independent variable, therefore this is known as PDE. And you see we differentiate the PDE and ODE by using the symbol curve delta here. So this is called the partial derivative. And D here is just the derivative. In this case, you have more than one independent variable, and also you have more than one dependent variable here. Therefore, this is known as the system of PDE problem. We will focus to solve the simple PDE problem in this study. Similar to the ODE case, you can identify the order for the ODE by looking at the highest derivative. So for example here, this is the highest derivative which is equal to 1. Therefore, the order for this equation is 1. And then for the second example here, the highest derivative is 1. So this is considered the degree. So this is not the order. Similarly, let's identify the order for the PDE case here. So for the first equation here, you have two independent variables, therefore this is PDE. Then you check for the highest derivative, which is equal to 1, and we can call this as first order PDE. Let's look at this example. So you have two independent variables, therefore this is PDE, and the highest derivative is 2. Therefore, this is second order PDE. Let's look at this example. You need to be careful. The highest order is equal to 1 as well. Is identified from the derivative. So here you have power 4. This is not the order. This is the degree. So we call this as first order PDE with degree 4. In this example, you have two independent variables. Therefore, this is PDE. And you check for the highest derivative, which is this. So this is called the second order PDE with degree equal to 1. Previously, to identify the linearity of the ODE, you need to arrange the equation in this format, where you have left hand side, you have the y, which is arranged in the form of y, y prime, y double prime, and so on. So this is the dependent variable. Then the coefficient a here, from a1 to an, must be in the function of independent variable x. On the right hand side, you have the coefficient without the dependent variable. So you see y is missing here. We arrange all the dependent variables to the left hand side here. If the ODE follow this format, like these two examples, then you will have a linear ODE. If it does not follow this format, then we have the nonlinear ODE. For example, in this case, you have the first order ODE, and this is known as nonlinear ODE because you have power of 2 here. For linear ODE, you have y, y prime, y double prime, and so on without any modification. So in this case, you modify the y prime to y prime squared. So this causes it to become nonlinear. In this example, you have the second order ODE where you arrange it by taking the dependent variable f on the left hand side and the remaining coefficient put at the right hand side. So you see for this term, you have 4f, which is the dependent variable. And if you compare to the format here, all the coefficients cannot have the y inside. So it can only have the independent variable. So this causes non-linear component. We are using the same approach to identify the linearity for the PDE. So this is the linear PDE format, where you have arranged the y, y prime, y dot prime, and so on, which is the dependent variable arranged in the left hand side. And then the coefficient attached to this dependent variable must be in independent variable only. So for the PDE case, we know that we have more than one independent variable. So over here, the coefficient must consist of independent variable only. Then you arrange the remaining coefficient at the right hand side. And this coefficient must consist of independent variable as well. And it cannot consist the dependent variable. For example, in this case, you have PDE because you have more than one independent variable. Then we arrange this formula by arrange the y term, which is the dependent variable, to the left hand side. And then after you arrange it, you should obtain negative this term equal to 0. So you have y double prime here, which has a linear format, follow this guideline. Then you check the coefficient, so all the coefficient here is in independent variable, therefore it follows the linear format. On the other hand, if you have the coefficient with the dependent variable inside, let's say you have x plus y minus y, like this case, so this will cause the nonlinear component. Therefore, you obtain the nonlinear PDE. Or you have the y double prime here with power of something, such as this case, and this will cause the nonlinear PDE as well. In this study, we will only focus to solve the linear PDE problem. So the nonlinear PDE is out of the scope. In the PDE, we can simplify this equation by writing the notation y. So if you differentiate with respect to t twice, then we put double t here. So this one we can write in this format y as x. Because y double prime here doesn't differentiate these two terms. So in many books, they do not use this. They're using this notation to represent the partial differential equation here. For the linear PDE, we can further classify them into homogeneous or non-homogeneous. You need to arrange the linear equation in the standard format, where left hand side it consists of the dependent variable and the remaining coefficient you put it at the right hand side. So if you see the right hand side term after you rearrange it is equal to 0, then it's called the homogeneous equation. Previously, you have learned how to differentiate the homogeneous and non-homogeneous ODE by looking at the right hand side. After you rearrange the equation into the standard format, where you have the dependent variable on the left hand side and the remaining coefficient you put at the right hand side. Now you check for the right hand side. So in this case, both of them are equal to 0, therefore you have the linear homogeneous ODE. So for these two examples, since you have non-zero result at the right hand side, then this is called the linear non-homogeneous ODE. We can use the same approach to identify the homogeneous PDE and non-homogeneous PDE here. So same, you arrange it in the standard format and look at the right hand side. So since these two cases you have 0, therefore this is called the linear homogeneous PDE. For the non-zero right hand side, then you have the linear non-homogeneous PDE. We will focus to solve the linear homogeneous PDE in this study. Non-homogeneous PDE is out of the scope. In this case, you have first derivative of u with respect to t and second derivative of u with respect to t. And in the ODE, we can simplify this term into u prime and u double prime. You need to be careful if the dependent variable u is a function that consists of two independent variables. Let's say you have t and x as the independent variable. So in this case, u prime will have two possibilities and u double prime has three possibilities. This is the possibility for the u prime. So it can be differentiate u with respect to t or differentiate u with respect to x. In the PDE, we don't use this symbol because it cannot differentiate these two derivatives. We are using the symbol like ut and ux here. Ut means the first derivative of u with respect to t, and you can expand it into this format. Ux means the first derivative of u with respect to x. So when you expand, you obtain this. Similarly, we don't use the symbol u double prime in the PDE. So we use the symbol utt, uxx, and utx or uxt here. Utt means the second derivative of u with respect to t, because you differentiate the u twice with t. So when you expand, you should obtain this. Uxx means the second derivative of u with respect to x. So this is the expansion result. And utx is equal to uxt because you differentiate x first and then differentiate it with respect to t is equal to you differentiate the t first and then take the differentiation with respect to x. So these two will give you the same result, and when you expand it, you should obtain this. So we can use either one of them. So if you have an equation written in this format, then you should know this is the PDE format where USS means the second derivative of u with respect to x squared. UXT means the second derivative of u with respect to x and t. Lastly, UTT means the second derivative of u with respect to t.